Today we are going to be looking at midpoint and distance in the coordinate plane. So because we're talking about the coordinate planes, we're going to be working with a coordinate, an X and a Y location in that coordinate plane. So we're going to start out with midpoint, either finding midpoint or using midpoint to find one of the other points. So when we're looking for the midpoint between 2 points on a coordinate plane, we're going to be given two coordinates, the two endpoints. So one of those endpoints would be our x sub 1, y sub 1. The other coordinate would be the x sub 2, y sub 2. So we're trying to find that midpoint, that middle piece in between those two given endpoints. So our midpoint formula says that to find the x value of the coordinate, we're going to add the x values, divide by 2. Okay? Because we're trying to find the middle or the average of those two x values. So we're adding them together, dividing by 2. We do the same thing for the y coordinate. Add the two y coordinates together, divide by 2 to find that middle piece. So when I look at this first example, I want to find the midpoint between the points -1, 4 and -3, -4. So I'm just going to first start out by labeling those two endpoints, x1, y1, and x2, y2. Now I plug those numbers into the formula. So for the first part, I add the x's together and divide by 2. For the other piece of the coordinate, I add the y's together and divide by 2. So when I work out my x coordinate, -1 plus -3 is how much? -4 divided by 2 is -2. 4 plus -4 is 0 divided by 2 is 0. So there is the midpoint of that segment. Okay, so between the points -1, 4 and -3, -4, the middle would be -2, 0. With this next example, M is the midpoint of segment AB. This time, though, I'm finding the coordinate of B. So I'm finding one of the endpoints being given an endpoint and given the midpoint. Okay? So this coordinate of B that I'm looking for, that I'm going to call my x2, y2. Okay. My x1, y1, I know. I need to find the x2, y2. So I still can use that midpoint formula. I'm just going to use it a little bit differently. I'm going to have actually an algebra equation I'm going to have to solve. So my formula says I take the two x coordinates. So I'm going to have 3 plus x sub 2 over 2. Okay? And I know what that's equal to. It's equal to the midpoint, 5. Okay? So I'm going to have to solve it for that x sub 2. So what am I going to do? November?
You're going to multiply by 5?
No, not multiply by 5.
Multiply by 1 by 2.
Multiply by 2.
I'm going to multiply by 2. So 3 plus x sub 2 equals 10. And then I'm going to subtract 3 from both sides. So x sub 2 is equal to 7. So I found the x part of the coordinate. Now I'm going to have to do the same kind of thing, only with my y parts. So I have y sub 1 is 7, plus my y sub 2 over 2 equals 10. So I'm going to do just like I did before. So I'm going to multiply by 2. 7 plus y sub 2 equals 20. Then I'm going to subtract 7. Y sub 2 equals 13. So not real difficult work, okay? But I'm going to show you now another way that you can approach this problem that you might think is a little bit easier. So if I'm thinking about my segment, I have an endpoint on one end, and we'll use the one we know. So we have this endpoint 3, 7. Then, if we're following that segment along, we get to our midpoint, which is 5, 10, and then we're trying to find that other endpoint. So if we're looking to the middle, we're going halfway, or an equal distance. Okay? We get to the midpoint, then we have to repeat that same distance, keep going. So if I look at my x values, if I'm going from 3 to 5, what did I do?
2.
I increased by 2. So if I increase by 2 again, I'm going to end up at 7. If I look at my y values, if I go from 7 to 10, I increased by 3. So if I increase by 3 again, I end up at 13. Okay. Same answer as what I had before. Okay. With the first problem, okay, the first problem when we're looking for the midpoint, okay, not really hard to put it into the formula, add them and divide by 2. Okay. But again, if you wanted to do that same kind of thing as what we did previously, okay, one of my endpoints is 1, 4. The other endpoint is -3, -4. I'm looking for that piece in the middle. What's halfway between -1 and -3? -2. What's halfway between 4 and -4? 0. Okay, same answer as we got before. So if you just think about what it is we're looking for, as far as working with the midpoint, okay, not that difficult to figure out. So whether you want to use the actual equation or want to use that other method, whatever works best for you. So that's finding the midpoint, that middle piece of that segment. The other thing that we're going to be looking at today is calculating the distance between 2 points on that coordinate plane. So this is where the idea of Pythagorean theorem comes in, which is why we went over Pythagorean theorem previous to this lesson. So I need to find the distance between these 2 points. Point A is at -6, 4, so I'm going to plot that point. and point B is at 5, 1. So if I'm looking for the distance between those 2 points, I would connect them. So I'm looking for the length of that segment AB. Because my segment is slanted, I can't just count squares because it's not horizontal or vertical. So I can't just count squares, but I can apply what I know about Pythagorean theorem. When we worked with Pythagorean theorem, we said it works for right triangles. So the first thing we need to do is make a right triangle. So I'm going to start at this point A. I'm going to go straight down till I'm even with point B, and then I'm going to go straight across. So I now have a right angle. If I wanted to, I could have went the other direction. I could have started at A. I could have went over to the right, even with B, and then dropped down. I still have the exact same size triangle. So now I've got my right triangle. This piece that I'm looking for is that hypotenuse, so that's C. And I can find the distance or the length of my 2 legs. So this short vertical leg is how long? 3. Just count my squares. The horizontal length is how long? 11.
Isn't it? Wait,
Okay.
I thought the 3 was supposed to be hanged. I'm just being dumb.
Yep. Okay. If we think of, no, you're not. You're thinking because we're going down, it's negative, which if we were calculating slope, okay, if we're calculating slope, then it matters. But when we're talking about length, the length is always positive. Okay. So it wasn't dumb at all. Okay. Okay, so now we've got our right triangle, so we're going to put that into Pythagorean theorem. So C squared equals 3 squared plus 11 squared. So again, you need to be writing that on your paper. Then do the math. 3 squared is 9. 11 squared is 121. 121 plus 9 is 130. So C squared is 130. I want to undo that, so I take the square root of both sides. Is 130 a perfect square? No. So we need to simplify it. What is a perfect square that goes into 130?
5 and 16. No, 5 and 26.
Okay, neither of those are perfect squares. 25 does not go into it.
I can split it into the 75 and the 2, and the 75 splits into the 25 and the 3. Yeah.
No. Okay, so, hey, you have been shown 2 different ways to simplify radicals, okay? If you want to do the factor tree, okay, you can continue to do the factor tree. When I show examples up here, I'm going to be using the perfect square method. That is where we want you guys to be headed to. Okay? It's a lot more efficient way to do that. Even if you can't get the biggest perfect square out, okay? What are our first 2 perfect squares other than 1? 4 and 9. Okay? 4 and 9. What's the divisibility rule for 4? How do we know if 4 goes into a number just by looking?
If it's even.
If you add them all together.
If it's divisible by like
4.
Anybody remember the divisibility rule for 4? A number is divisible by 4 if the first 2 digits are divisible by 4. So does 4 go into 30 evenly? No. So it's not divisible by 4. So then we could try 9. Who knows the divisibility rule for 9?
Isn't it like you add together all of
It has to be equal.
okay. Well,
Yep, you're right, Grace.
okay, so if you add up all of
The digits.
so like 1 plus 3 plus 0 is 4. So 4 is not, you can't divide 4 and 9. 9 by 4, so.
Okay. Right. Okay. So 9 does not go in. The divisibility rule for 9 is if the sum of the digits is divisible by 9. So 1 plus 3 plus 0 is 4. 4 is not divisible by 9. So 9 doesn't go into it. Okay. So we could keep going with our bigger perfect squares, okay, because there could be something else. If you get stuck with that, then try your factor tree. If we were doing a factor tree, what would we multiply together to get 130?
9 and 15.
10 and 13. Okay, so we branch it 10 and 13. Whoops. What can we do for 10? 2 and 5. What can we do for 2? Nothing. What can we do for 5? What can we do for 13? Nothing. So what is our answer going to be?
13.
Where do I have?
65 on the inside and then 2 on the outside.
I have a 2, a 5, and a 13. Where do I have a pair that comes out?
2. What? 130. I don't know.
I do not. Hey, look. I do not have a pair to come out. Nothing comes out. So it all gets multiplied back together and equals the square root of 130.
Does that mean there wasn't a perfect square that went into it?
There is not a perfect square that goes into it, right? It cannot be simplified.
Did all that work?
Okay. Next one.
That one's special.
Point C is at -2, 6. Point D is at -2, -2. What's the length of my segment? 8. Okay. Because it is a vertical line, we can just count the squares. If it was a horizontal line, we could count the squares. When it's slanted, like in number 1, we have to use Pythagorean theorem. Number 3, point A is at 7, 0.
So the answer to number 2 would just be
Right.
Oh, because it's vertical. I got it.
Okay. Point B is at -5, -6. So if I connect my 2 points, I've got a slanted line, so I have to do my Pythagorean theorem. So you can either go up and then across, or you could go cross and then up. Either way, you're going to get a right triangle with sides the same length. So again, the piece I'm looking for is C. What is the length of the vertical piece? 6. What about the horizontal piece? 12. So Pythagorean theorem, C squared equals 6 squared plus 12 squared. 6 squared is how much?
Why do you
36.
have C squared on the left? It just kind of throws me off.
It doesn't have to be on the left,
Okay.
okay? Right, when it's an equal sign, okay? What I can tell you though is later on, we're gonna be working with triangles, and if it's not a right triangle, how to determine if it's acute or obtuse. Okay? And the way that we make that determination makes a lot more sense if your C squared is on the left.
Okay.
Okay, so that's why I've been doing that. Before that, I always typically put it on the right until we started teaching the inequalities. You just set it on my desk. Thanks, Matt. Okay, so that's why I do.
That's
Zach, I'm sorry. That's why I do the c squared on the left. Okay. But again, when you're working with an equal sign, it doesn't matter. Okay, so we have 36. 12 squared is 144. So when I add them together, I get 180. So then I'm going to take the square root of both sides. Okay, is 180 a perfect square?
Yep, it is.
No, it is not.
No, I'm done.
Okay, so what is a perfect square that goes into 180?
9.
Okay, so square root of 9 times what is it 180? 20. So 9 times 20. Okay, so what about 20? Is there a perfect square that goes into 20? 4. How many times does it go in? 4 times 5. Okay, so I have a square root of 9, a square root of 4, and a square root of 5. What's the square root of 9? 3. What's the square root of 4? 2. What's the square root of 5? Square root of 5. 3 times 2 is 6. So 6 square root of 5 is my answer. Okay. Number 4, distance between point A at -4, 0. Point B is at 8, -3. So, again, I start out by making my right triangle. I went down and across, or you could go across and then down. So how long is my vertical piece? 3. How long is the horizontal piece? 12. I'm looking for C. C squared equals 3 squared plus 12 squared. What's 3 squared? 9. 12 squared, 144. Added together is 153. I need to take the square root of both sides. What's a perfect square that goes into 153?
9.
9. How many times does 9 go into 153?
17.
17. What's a perfect square that goes into 17?
Nothing.
There isn't one. Square root of 9 is how much? 3. So 3 square root of 17 is my answer. So again, if you prefer to do the factor tree rather than that perfect square method, that is completely up to you. I'm going to keep pushing this perfect square method as we go through examples from here on out.